out, and I'm just going to have you solve a quadratic equation that has imaginary solutions just to show you what it looks like. So, quadratic equation, how many answers should we have to this? 2. Okay, now we can't factor this, like no, nothing's multiplying to 13 to get you -6. So we pretty much have 2 options. We're either going to do the quadratic formula or complete the square. Either one would be okay here. Do you guys have a preference? Oh, I was like, no one has a choice. Okay, quadratic formula it is. All right, she said it first. Okay, and you guys, we have these formulas up on the board, test, quiz, final. We'll give you all these formulas. You don't have to memorize them, so I'm just assuming that you have access to look at that if you're not sure about it. So I'm going to do opposite of b, so it's going to be 6, if my pen will work, plus or minus square root. And let's just cheat and use the calculator a little bit here. Not cheating, using our resources. Okay, so b squared is -6 squared, 4 times 1 times 13. Excellent. I got -16 would be my discriminant, my b squared minus 4ac. That's just what's under the square root. Everybody over 2a, so here 2 times 1 would be 2. What is the square root of -16? 4i. All right, perfect square in imaginary land. So I have 6 plus or minus square root of -16. We would just simplify that to be 4i. Everybody over 2. Can we simplify that? For sure. Sometimes people get tripped up. They'll be like, oh, I can't do that. You can always reduce stuff as long as it has to be all 3. It has to be the 6, this 4, don't worry about the I, and the 2. As long as those are all divisible, which they are by the same number, this is all divisible by 2, you are actually allowed to divide that. So 6 divided by 2 is 3. You'd keep the plus or minus symbol in between. And then 4 divided by 2 is 2, so that would be 2i. All right, now, just like yesterday, I'm going to separate this real quick. Normally, just leave the answer like that. That's cool. But just to make sure you guys know, this is 2 separate imaginary numbers. 3 plus 2i, and I just started to write the wrong thing. 3 minus 2i. So it's 2 separate answers. And I'm going to show you guys this just if you want. You can actually check this with your calculator pretty quickly, even though it's an imaginary number. Like if I do x squared, I'll just do one of them. I'm going to do 3 plus, now I typed 2, and I think I told you guys the other day, if you have a graphing calculator, it does have a button that will do I, not the letter I, like if you're doing the text with the alpha keys, but down here, the decimal point, the second function on that is actually I, the imaginary number I. So if I plug that in for x, we do this, and then I'd have -6 times that 3 plus 2i, and then plus 13, and you just hit equals. It does write it in the format of an imaginary number, so a being the real part, 0, plus bi being the imaginary part, but that is 0. It's just a way to write it in imaginary or complex number notation. But you could check these really easily just using your calculator to make sure you had your answers right for any of these questions if you want to go back and look. Okay, now, these 2 answers, right? We were supposed to have 2 answers. These are what we call conjugates, just like yesterday, but these are imaginary conjugates or complex conjugates. All right, so the format is a plus bi and a minus bi. So it's the same thing. They're not opposites of each other. They're all the same except for the sign in between. That's what a conjugate is. One's a plus, one's a minus. They're not opposites. If you add them together, they don't cancel each other out or anything like that, but they are conjugates. They just change up the sign in between the 2 terms of your lovely complex or imaginary number. Now, super similar to yesterday. If you have an imaginary root, if a plus bi is a root of your polynomial, 0, answer, whatever you want to call it, then its conjugate, which would be a minus bi, is also going to be a root. And I could switch those up too. I could write a minus bi first and a plus bi second. So same thing. If you have one, you automatically have the other. So imaginary roots, and I'm just going to make a note of this. We did irrational roots yesterday. Those are real numbers. They're just nasty decimals. These are imaginary roots. So this will be actually more helpful for our last lesson, but I'm going to write this. Because you have conjugates, imaginary roots always come in pairs. So if I'm looking at a graph, you can't have like 3 imaginary answers. If you have 1, you automatically really have 2. If you have 3, you would really actually have 4 because they have to come in pairs. So whenever you have an imaginary answer, there should be at least 2 of them, and they have to be in even numbers. That'll be a little bit more important for what we're going to do next week. But just to tell you that here so you have it in your notes. Okay, so this is just like yesterday. If you have an I somewhere in your number, you have a conjugate, so it will have an additional root. So if I tell you, like on this one, 2 plus 9i is the root, then automatically 2 minus 9i is also a root. So it's going to ask you if you have any additional. If you see a square root, you automatically have a conjugate. If you see an I, you automatically have a conjugate. All right, now, does anybody know what the conjugate for negative 7i would be? Just 7i. And you don't need to write this or anything like that, but I could write that as 0 minus 7i and 0 plus 7i if I wanted to write it in that a plus bi format. But yeah, just if you have an I, it has a conjugate. Just switch up the sign. So that has a negative in front of it. You can write the plus sign if you want to. I just wrote 7i. That's implied that that's positive. Okay. Who can raise your hand? Tell me, what would you write for the conjugate of negative 6 minus 5i? Yes. Don't change. Only change the sign in the middle. If it starts with a negative real number there, which it does, negative 6, don't change that. You only change the sign in the middle. All right. What would you write down for the conjugate of positive 4i? Negative 4i. Everyone fell asleep for a second. Okay, negative 4i. All right, what about the number negative 15? That is just a number. There's no radical, there's no I, so don't be writing positive 15, okay? So you don't get any additional roots from a plain number, all right? Just negative 15, it's all alone, it's by itself. No conjugate. All right, if you see an I, though, like 7 plus 3i, then that does have a conjugate. So if you see an I or you see a radical, you got a conjugate. If you don't see an I, you don't see a radical, do not write the opposite of that number, because it is not a 0. Okay, does anybody have any questions? All right, so very similar to yesterday, but I'm going to remind you of one important thing for all the questions today. Now, by definition, you're not really going to use this part today, but I is defined as the square root of negative 1. What you're going to use today piggybacks off of that, and you got to remember, if you have I squared, by definition, that actually becomes a real number, and that turns into negative 1. All right, and you're going to use that in literally every question today. So you got to remember, I squared is going to turn into a real number. It's going to become negative 1. So I'm going to write this polynomial. We'll eventually do it in standard form, but we're just going to do factored form first. So one of my zeros or roots or answers, whatever you want to call it, is 6. And what little set of parentheses, what little factor would go with 6 being an answer to my polynomial? If I have positive 6, what would it look like as the little linear factor? Mom, what do you think? Thank you. Everyone's so quiet this morning. It's Friday. All right, now, negative 9i, right? We're just going to, similar format. So if that's negative 9, I'm going to write x plus 9i. Okay, now I got to remember though, if I'm seeing an I automatically should have a second root, which would be its conjugate. So they didn't write it here for us. That's mean, but whatever, we can write it ourselves. So if negative 9i is one of the roots, then its conjugate, which would be positive 9i, is also a root. And then just to write the little linear factor for that, it would just be x minus 9i. Okay, super similar to yesterday. We're going to multiply this out to put it in standard form. This would be factored form. I just wrote the linear factors associated with those zeros. Okay, you can multiply like x minus 6 times x plus 9i. Don't do that. It's super annoying and it's going to take you longer to do. So if you have conjugates, multiply those two together first. You're just going to multiply 2 at a time, but take and do the conjugates first. When you do that, all the imaginary parts will cancel out. All right, so just doing like a little FOIL here. So x times x give you x squared. Now I'm going to write these on this question, but if you want to skip these, like if you're doing your homework or something, that's fine. The two middle terms are going to cancel each other out. So if I do x times negative 9i, I'm going to get negative 9ix. And the format for that, if you have two variables, and I is not a variable here, it's a number, but if we have two letters in the same term, you just write them in alphabetical order. Okay, but then I'm going to turn around and get 9i positive times x positive, which would be positive 9ix. So those two terms will cancel each other out. The last term does not. Okay, so you will always have positive number times a negative number because one's a plus and one's a minus when you work with the conjugates. So 9 times negative 9, this will be negative 81. And then you're going to have I times I, which is I squared. Okay, now I'm just going to kind of do this to the side here. What is that term going to be equal to? Because it's going to be a real number. You really have negative 81, and then I squared is equal to negative 1. So this actually becomes positive 81. When you were working with the irrational root theorem yesterday, those terms on the end, the number was always negative. If you're working with an imaginary number, that number on the end, when you multiply the conjugates, should always be positive because your coefficient, you're going to have one of each, positive and negative, and you're going to get an I squared. So you'll always have a negative times a negative. So this would be x squared plus 81, just simplified. That middle term cancels out. And then to get my actual polynomial, we had another 0. We had 6. So I got to bring down that other factor real quick. We had 3 answers, so we should have a cubic, and I only had a quadratic at that point. So I'm just going to do a little FOIL again. You get x cubed, bless you, plus 81x minus 6x squared. I don't know what that is. Give me a second. 6 times 81 is 486, so minus 486. Now, not always, but sometimes when you're working with these, as I go through the problem and as I did my FOIL, it's not in standard form because the powers of x don't go in order from least or from greatest to least. I just have to switch up those two terms to write my answer correctly. So it should be x cubed minus 6x squared plus 81x and then minus 486. Does anybody have a question? Okay. All right, now, just like yesterday, I'm going to use the box on this. Okay, if your imaginary number has two parts to it, if it has a real part and an imaginary part, the one we just did just had an imaginary part, didn't have a number in front. First of all, automatically, conjugate, they come in pairs, so automatically 2 minus 5i is also an answer here. And I'm going to set this up the same way I did yesterday. All right, so whenever you set up these linear factors, if you got two pieces, I promise, just use a subtraction sign. Just use a subtraction sign and take the imaginary number and put that in parentheses if it has two parts to it. So I'm going to do 2 plus 5i. Okay, and I just want you to think about this for 1 second. If I take 2 plus 5i that I highlighted with my lovely little yellow marker, if I put that in for x, if I did 2 plus 5i and then I did minus 2 plus 5i, that would become 0. So that's how I would set up my factor. Now, other one, don't change it. You're just going to use subtraction again. Just use subtraction, and I'm going to put that conjugate in parentheses if it has two pieces. So it's 2 minus 5i. Now, what we did yesterday, remember, before we want to multiply, I'm just going to simplify these factors a little bit by getting rid of that extra set of parentheses. It's just going to multiply both of those terms by a negative 1 when you do that. So I'm going to have x minus 2 minus 5i, and then x minus 2 plus 5i. Okay, now I'm going to full on show you this for this example, but the box I'm going to draw here is going to really be similar to what we did yesterday with the irrational root theorem, and the same parts are going to cancel out, but I'm just going to full on do it for this question so you can see. But going forward, if you want to cross out, it's the same boxes I'm going to cross out that we did yesterday. All the imaginary parts should cancel out if you have done this properly. I'm going to do the x minus 2 minus 5i down the side and the x minus 2 plus 5i down the side. Okay, now, I promise, and I'm just going to show you this on this one. It's like yesterday, just these 4 boxes and this one in the corner are going to be where you have actual terms. Everything else will cancel out, but I want to show you at least for one question that they do cancel out. So, if I multiply everybody by x here in this top row, I'm going to get x squared minus 2x, and then these are both positive, so positive 5ix. I'm going to do second row, multiply everybody by negative 2, so negative 2x. Now, this number in the middle, it should always become positive. You're either going to have 2 positive numbers multiplied together, or in this case, 2 negative numbers multiplied together, so that's going to be 4. Negative 2 times 5i would be negative 10i. You can always multiply numbers together. They don't both have to be real. You can only add or subtract if they're like terms, though. So that's going to become negative 10i. Now, this guy right here, negative 5ix. Negative 2 times negative 5 is positive 10, and that has an I with it. And then down here in the corner, you'll always have a negative number, because it's going to be negative 5 times negative, or negative 5 times 5, which is negative 25. But then I'm also always going to get I squared. So this little box in the corner is negative 25 times negative 1. So that little box in the corner is actually going to be positive 25. That if you're working with imaginary numbers, that little number in that bottom box should always be positive. If you're working with irrational, it's actually always negative. Okay, and then you guys can see from here, here's positive 5ix, negative 5ix, negative 10i, positive 10i. So those cancel each other out just like they did yesterday, same spots. All right, so you get x squared. These don't cancel. They're the same. They're negative 2, so that's 2 negative 2's, so it's a negative 4x. And then you'll have to combine the number in the middle. Let me grab a little marker to highlight that. You're going to have to grab this number in the middle, and then once you simplify, this is from this bottom box. So the 4 and the 25, those will be combined for like terms. So this would be 29. This would be my quadratic that has 2 plus or minus 5i as the solutions. Is anybody having a question? Okay, we'll do one more that's a little bit harder. So this has an imaginary root, but it also has a real root. All right, so if you have imaginary, you automatically have another one. If they don't give it to you, just write down its conjugate. So I'd have negative 7 plus 4i. And then we also have this 3. So I'll just start out. I'm going to go ahead and write the factor for the 3. So we have a 3, so it'd be x minus 3 would be my linear factor that would go with that. All right, for my imaginary roots here, I'm going to do x minus, and then I'm just going to put the imaginary roots in parentheses. But both of them, I'm going to use a minus. One of them will be negative 7 plus 4i, and one of them will be negative 7 minus 4i. Now, this one's just slightly different than the one above because that real part of that is a negative number. So if I distribute that subtraction symbol, this will actually be like a negative times a negative, so it becomes positive. So here's what I got. I've got x minus 3, then I've got x plus 7 plus 4i, and then I'm going to have x plus 7 minus 4i. As long as you have those 3 factors, it does not matter what order they come in. Okay, so it can come in any order. But again, you're going to multiply 2 at a time here. You could multiply x minus 3 times one of those longer factors and then continue to go from there, and the imaginary parts would all cancel out. But do not make life hard for yourself. Just multiply together the conjugates first, and that'll automatically cancel out all the imaginary parts, and you won't have to worry about it. We'll go back and multiply it, our answer, by the x minus 3. Okay, so I'm going to just draw a little box here. All right, now I showed you all on the last question, it's just the same boxes as yesterday that cancel out, so I'm not even going to fill them in. We're not going to waste our time. So I have, let's see, I'll do the plus 7 plus 4i down the side and the 7 minus 4i across the top, but that should not matter. We're going to have x squared, 7x again, 49. Okay, can anybody tell me what should be in this box? 16, yes. Okay, so if I do 4i times negative 4i, I get negative 16i squared negative 16 times negative 1. So that box should be 16. Okay, now we're just going to put together, like I told you, it's just these 4 and this one in the corner. All right, so what do we have? Okay, x squared plus 14x, and then we're going to take 49 and add 16. Do not judge that I'm using my calculator. I totally just did. So 65. Now, here's just this question itself. Oops, let me pull it back down so you can see it. This had another actual real 0, like we could have seen this on the graph. So x minus 3 was another factor. So then this one, I just have to foil or box with these to get my final answer. Completely up to you. I'll tell you what, I'm just going to use a box again just because I've already used a box today, so I'll just do it again. All right, I'm just going to make it 2 by 3. So we have got an x minus 3, x squared, 14x, and then I got 65. So we're going to get x cubed, 14x squared, 65x, negative 3x squared, negative 42x, and 65 times that negative 3 is going to give me negative 195. All right, so polynomial in standard form with the zeros we had to start the question. We're going to have x cubed plus 11x squared, and then plus 23x, and then minus 195. I know that's a lot of work, but it's not terrible to do if you use that little box and just kind of save yourself some time by not filling in the parts that you know are going to cancel out. Is anybody having a question? Super similar to yesterday. Okay, so as you start your assignment today,